Hello everyone, welcome back to the channel. I hope you guys are doing amazing. So this is our video 4 on the DP series, and we will do today some knapsack-like variations, some famous problems of Leetcode, which is coin change and coin change 2. Okay, so first of all, if you have seen my previous video on knapsack, on how to write the DP 2D DP things, okay. So by following those same steps as recursion, memoization, and tabulation, so then you should try this problem first on your own. You should definitely try these problems on your own first, and then continue with watching the video. So yeah, you can go to the Leetcode and just check this coin change problem. Okay, so this coin change, let's look at that. So we have the, first of all, an amount will be given. Let's say that amount is 11, and we are given a coins array which will show that what is the denominations of the coins which we are having. So we are having a 1 rupee coin, 2 rupee coin, and 5 rupee coin, and each coin I am having in infinite amount. Initially, each coin and I am having in infinite amount. Okay, so question is that what is the minimum number of coins? Minimum number of coins. What is the minimum number of coins you will need required? So what is the minimum number of coins required to form A? From this A, okay, from this A equal to 11. Okay, so here you can see that here 5 is there, so it's a large amount. So you can take 5 plus 5 plus 1, you can take, so that forms 11, and we are taking 3 coins. Okay, so for this test case our answer will be 3. Our answer will be 3. But if you are thinking a greedy method will work here, then that will not work. Why? Let me take an example and show you. Let's say now amount is 12. Okay, amount is 12. Coins is something like you have the denominations of 1, 4, and 5, and you are asked what is the minimum number of coins. If you try to greedily pick and complete this A, you will first choose this 5, right? Because it is the most maximum value. So you can choose 2x number of 5 coins. You can choose 2x number of 5 coins, which will give you an amount of 10. Then you will end up in choosing 2x number of 1 coin, which will give you an amount of 2. So for getting this total amount of 12, you ended up in choosing 4 coins. Okay, you ended up in choosing 4 coins, and you got 12. So 4, you will think that 4 is the answer, but 4 is not the answer. What you can instead do is that you can pick 3x number of 5 coins to get 12 directly, and your coins in this case is 3 just. So this is the minimum amount. This is much less than this. Okay, 1 less than this. So in this, so this shows that if you are thinking of any greedy approach, it terribly fails here. It fails, greedy fails. So definitely if it fails, you will just try to look at DP, and this looks like the knapsack problem also, right? Quite similar, not the exact same thing, but you can check that this is something like this knapsack is you are having, right? It can hold a maximum of 11. So you are required to form a little bit problem statement is different. So you need to think a little differently, but the approach here will exactly be the same. First you need to write a recursive solution. Okay, you will go in the exact same approach as I have told you. So you will go write a recursive solution to it. Then you will try to memoize it. Okay, and then you can go for the tabulation method. Okay, and if you are quite well versed with DP, you can just directly try to write the tabulation method. Okay, no problem with that. So let's see. Let's try to solve this problem. Let's try to code it out and solve the problem. Okay. So let's just check it out on Leetcode. So we have it, right? Okay. So as I told you, I will have some recursive functions. So first of all, you will identify the states. What are the states? You will have an iterator which will go through the index of the array. So first of all, you have the index state which will go till n. Okay, and you also have the state of current amount, right? If your current amount is equal to the total amount, then only you have one way. Okay, if then only you have the task which is completed, right? So the current amount needs to be equal to the total amount. So you have two states in this recursion. So you can just call this recursion function. You can look to directly solve it. Okay. you can call the recursion function. Let's say without directly returning, I am telling that answer equal to scalp. Okay. You pass the coins, you pass the amount, you pass the index 0. You are starting from 0 and initially you have empty, your bag is empty, right? So and you return answer. Okay. So you can just calculate this, write this calc function, right? So this calc function returns what is the minimum number starting from index 0 and this current. Okay. So you can write this coin. Okay, you just try to implement this. First thing in recursion, as I've told you already multiple times, that is comes the base case, right? The first thing comes is the base case. So you need to write the base case first. So first of all, you get an n, this is size of the array, right? Okay. So what you will do, you need to return the minimum value, right? You need to return the minimum value. So first of all, the thing is that if you get something like the current amount is getting equal to the total amount, you return 0. Because if I have the 0 amount and my current amount is also 0, I don't have any more coins to take. I don't have any more coins to take. I will return 0. Okay, I will return 0. I don't have any more coins to take. And if you are iterating through the indices and you reach the last index, okay, and you reach the last index or some greater than the index, which is n, okay. So if you reach the last index, you do not have any more coins to take, and amount is also not formed yet. So amount is also not formed, and you have reached the last index. Okay, so it means that there is no way in which you can pick the coins. So what can you do here? Try to think. Should you return 0? Should you return 0? Answer is no. You should not return 0, because return 0 means what? I have already made my answer and I am returning 0 more coins required. But what I tell you that infinite more coins are required. So I am in a way telling you that return infinity, right? Return infinite more coins required. So what will be the maximum value of the coins? If you try to see, this amount is 1e4. It can go till 1e4. In the worst case, I can take a coin of denomination 1. I can take a coin of denomination 1 and do it 1e4 times. 1e4 times. So for safety, I'm taking my infinity value to be 1e5. Okay. First I'm taking 1e5. You can take 1e4 plus 1 also. It doesn't matter. So if I am not able to form the amount sum and I have reached the last index, then what should I do? I should tell my recursive function that there are infinite coins which are required to form this. Means it is not possible to form this amount. Okay. I'm telling that these infinite coins are possible, because at the end, I have talked about many times in the take not take DP. I will do some take, I will do some not take, and at the end I will return this minimum of take not take, right? Minimum value I will return. So if one of the function is returning 0, how it's possible? Then it's going in the favor of that minimum, right? One of the function, if you want to eliminate this take or not take, you need to return infinity. Okay. So that we will see, that we are just going to see when can you take. So first of all, let's initialize this take also as 1e5. Okay. It means that initially I am telling that there is no way to form this. Now how if you can take, what does that mean? If your current amount, you're adding the coins in the current index, okay, adding the coins of the current index, and still it is becoming less than amount. It is becoming less than amount, then only you can talk of taking it, right? Then only you can talk of taking it. So now you can set take as calc of coins amount index plus 1. You go not index plus 1, because if you take the first coin, you may take it again. You can choose to take it again. So you stay at the same index. If you take a coin, you stay at the same index, and the current value get increased to coins of index. Okay, it just gets increased to this. This might cause some error, because see, it's coins of this int max, almost this int max, right? So what I will do is that I will as define this LL. I have already as defined this LL. Okay, so I will do some long here. You can just get it. Okay. So if you not take, what you can do, either take the current coin or not take. So if you do not take the current coin, it means that in future also you will never take the current coin, right? Because if you had to take at least once, you just take it now. What you are thinking? So in future, if you will not take, then this coin, I will just move it. I'll just move it. Okay. So if you tell me to consider the case where the 5 is considered twice. Okay. So at first I will go to this stake and tell you that 5, the amount 5 is taken once. The amount 5 is taken once. And then I will again go and tell that amount 5 is again taken once. I am staying in the same index. Then again, the pattern which will follow for 2 5 is that take 5. Okay. Then take 5 again. Okay, then not take 5, not take 5. It means that it will go to the next index, and as a result, I have taken a total of 2 5s. 2 5s taken. Okay. So in this way, I just do the stake. Okay. So if I'm not taking, definitely my current will remain as it is. It will not change. It will not change, and I will return nothing but minimum of take and not take. So if you are having any difficulty in understanding any of this, because you need to see my earlier videos, okay? Because this is the same, it is very simple recursive thing which I am doing. I'm not doing anything extra, not thinking so much or nothing extra I'm doing, okay? This all the same thing which I've done earlier for a 2D array also. So this is how you write the recursive solution, right? This is how you write the recursive solution. You first write all the base cases, and then you do take or not take. If you are in the index, you can choose to take or not take, and then you accordingly write the recurrence relation, and you return minimum value obtained by taking and not taking. Okay, so if you try to run this, and check, uh, I have not initialized this as integer. Okay, we are getting a wrong answer. We can check that what exactly is the problem with this. Okay, so if you see, this might also return -1, right? This might also return -1. So the thing is that I need to check that if answer is telling me that it is not possible to form, there are infinitely many coins required, then I will return -1. I'll return -1. Otherwise, I can go with the answer. Otherwise, I will go with the answer. Is there any more error? So let's try to run and check. Uh, there is still this error going. Okay, I have 2 1 and 3. Okay, so I'm telling that if this is less than amount, then you can choose to take it. If you take it, you have the index of this same and coins of index. Okay, and if you not take it, you have the coins, you have the index +1, and you have the current. You have minimum of take not take also returning with you. So one thing is that I am missing here is that I am not returning anything, right? It is not adding up anything. The output is 3. Where this 3 is coming? So if you are taking, definitely you are using one coin. You are using one coin. What does this calc return? It tells the number of coins, number of minimum coins, right? So if you are taking one coin, right? So you need to add this one coin that you have taken. So that I was missing it out. So yeah, we do have the accepted thing. If you try to submit it now, you should get a TLE. Yeah, you should get a TLE. This is a recursive solution. So in order to memorize it and write it, so I will do nothing but a simple DP array. Okay, simple DP array. I will do it. I've shown you multiple times of how to initialize all these. So just I will write a 2D DP, right? Because the vector is having 2 states. So I have this 2D DP with me. The first dimension, I will choose it to be n+1 because it is the index. And the second dimension, I will choose to be amount +1 because this is the current value which can go up to amount. And all the elements needs to be initialized with -1, as I have told you already. We need to do it. And for this, I have this DP. I will pass it as the last function, last argument of the function, and I will have this vector of integer DP with me. I will have this. Okay. So now what you can do is that if DP of index of car is not -1. That is, if it is not empty, then return it. If my place is not empty, you are doing a catching thing kind of thing, right? Returning it from sort of cache memory, okay? And if you have -1, that is, if it is empty, then definitely save the state. Definitely you should save the state, right? This is the current, and this is the current, not current, okay, index and current, and you should save this minimum of take comma not take, and you should always return. You can also return this also, no problem with that, but you should return this index or curve for a good habit. So this is all you need to do, and for even online tests, this much is sufficient to do to get a correct answer without any TLE. This will not give the TLE, and you have the solution with you. You have the solution ready with you. So okay, so still it's going to be showing a TLE. So why so? I am not returning this, right? Not returning this anyways. So return statement I had missed. You need to return that value only. So you see the accepted thing is here. The accepted thing is here. So how can you make it better? How can you make it better? So the interviewer might ask you to write a tabulated form, right? So write a tabulated form. So you need to write the base cases. Base cases are nothing but here, right? So if you, and you need to start from bottom up. It's bottom-up DP. So you need to start from bottom up. So all the cases where this current is amount, okay, I'm returning 0. So what does this mean? So first of all, DP of ij will denotes starting from index I, and this value j, how can I complete, in how many minimum coins can I complete the amount, okay? How many minimum coins can I complete the amount? So if you see, if I am at index n, if I am at amount n, okay, if j is equal to amount, so what will that mean? Okay, what will that mean is that I have already created my amount. So it means that I need 0 more coins. Okay, so this is one of the base cases which I've already written here, right? If current is equal to amount, I need 0 more coins. So let me fill that in the DP array. So I will go from I equals to 0 to, you can call it j, you can just call it j for your own mental thing, right? So I will go through this all. I will go through all the indices, no matter in which indices I am. I will set this DP of j and amount. Okay, so no need to say this j. Let this be n only. The next one we can say it to be j. Okay, so this amount is nothing but 0. Okay, I need 0 more coins. Okay, j, the second argument is j. Okay, so now you can tell me that if I equal to n or greater than equal to n, so it means that I have passed the array. And no more. So can't form the amount. Okay. So it is a way of saying that I need infinite coins to form the amount. Infinite coins needed. Okay, so how will you set the infinite coins needed? I have already mentioned it here, that if index is greater than equal to n, so you just set it. If I set it to be something like equal to n also, then there's no problem, it will work, because it's already only going by one amount. It's increasing by one amount, so it has to pass through n. Okay, so what I am doing now is very simple, very easy. You just write this thing, I equals to 0. You can go from let's take j now. And you can go from all the way till amount and this j plus plus. Okay. So what you can do here, is that if you can do that DP of n. If you have exhausted all your indices, you have passed the array, then what you will do for all amount, if you have passed the array, if all amount apart from this last amount, okay, the last amount means you have already formed it. So anyways, that will not be required at all. Anyways, that will not be required at all. You set it to infinity. As I told you, set it to infinity. Infinite coins are needed. And the remaining same thing, you just need to write a bottom-up DP, as you can understand clearly. Okay. So you need to write this bottom-up DP. Is it need to write bottom-up, right? So yeah, you need to iterate backwards, as I've already explained you many times. So why we do this bottom-up things? Because you can check that if you try to draw the table of that DP array, this is the last row and this is the last column. Okay, last row and last column, we are filling it up. You will require those values. You will require those values since the index is +1, +1 with the value after that. You need to fill with from the last. You need to fill from the last. Let's take the amount to be this minus what? J greater than equals to 0, j minus minus. What you can do is you can copy the same recurrence as I told you. I've already told you in the steps that you need to first write the base case in conversion from the recursion, in conversion from the memoization to tabulation. You just need to write the base case first and just copy the whole recurrence. Okay. So how you will copy this? You just take it like this. Okay. Select it like this and just copy it. Just copy it, and you need to do not much, just the ornamental things you need to do now. You know that I is nothing but this index, and j is nothing but this current value. Okay, current sum. So wherever you can see j current, you can just replace it with j, and index you can replace it with I. Okay. And this take is nothing, calculate is nothing but this DP. You get rid of the unnecessary states. You get rid of the unnecessary states. Okay. And what you do is very simple, very easy. You just replace this current as well as this index with I and j respectively. Okay. So that only I'm doing. Let me do it. Okay. So I have it. Current is nothing but j, so I will write j here. And I have it. Okay. The remaining things is the same. Okay. Again, this is j. This is dp ij. I'm filling it in this way. And do you think what we need to return? DP of 0, 0. So I'm starting from the initial element, and I need to fill the whole thing. So DP of 0, 0, I need it. So I will just write here DP of 0, 0. Okay. And that is what we need to do. And this whole calculate thing, we don't need to run at all. Okay. So let's try to submit it and check if it works. We have the accepted thing. Let's try to submit it now completely. So you see, we have the accepted thing. It's giving an okay runtime complexity, but that's all. That's all you can do it. Okay. And for this coin change too, the exact same thing, almost the exact same thing. The problem, let me just read the problem. You're given an integer array coins representing coins of different denominations. Okay. You need to return the number of ways to form this amount. Okay. So you don't need the number of coins this time. You need the number of ways. So like 5 can be written as this, and this also. Okay. So the same thing, you can just check it out. Greedy won't work here. You need to check the number of ways. So I am just quickly writing the recursive function for this. Okay. So exact same things which we did earlier. Exact same thing which we did earlier. So let's do it now also here. We write the recursive function first. The amount we have, the coins we have, we are starting from index 0, and the currently we are having a 0 amount with us. Okay, 0 amount with us. And as I write, I cannot write the same function again and again. I write the cal here, and if you just write cal here also. Okay, so what will happen? I will just write the function quickly. Okay, and I have the indexes, I have the current amount with me. The now base case will be different because problem is different. So what you need to do here about the base case, first you need to generate this n, then only you can talk about base case. If the current amount becomes equals to the amount, what will you return now? You will say that I have got one way. Here you return 1, not 0, because earlier I was returning 1 because 0 because there were no coins to be left, like I won't use any more coins. But here if I am done with the amount, if I have my current is done with the amount, I have one way and I need to return the number of ways. So return 1 because I have finished looking for one way. Got a way. Okay, I got a way to make amount. So if I got one way to make amount, got one way to make amount, I return 1. Okay, it's very easy, very simple. And if you have something like I greater than equals to n, or I equals to n, you write it, you return 0, because if you have reached the end of the array without forming the amount, you have not formed the amount, you have not entered this loop, means you have not formed the amount, and you have reached the end of the array, it means that you got 0 ways. You got 0 ways. Okay, so you have it. So you have it now. Now the same take not take I will do. I initialize take as 0 now, and the same thing I do the exact same thing. If I add this current value with this coins of index, if I'm taking the coin, if I'm taking the coin, and if it is still less than equals to the total amount, then only I can take it. Then only I can talk of taking it. And when I am talking of taking it, I have the amount with me, I have the coins with me. I want to stay in the same index because I might take that again, I might take that value again, but my current value will get increased by coins of index definitely. And if I choose not to take it, if I choose not to take my value, okay, so what I will do, I have the amount with me, I have the coins with me. Okay, uh, what I need to do is I need to return index plus 1. If I'm not taking it, I will not take in future also. I just go to the next element and my current remains current as I have not taken. Okay. Now what you need to do, you need to return minimum. No. You branch two ways of take and not take, and then you add the values. Then you add the values. So return take plus not take. So all the ways by which you got to take the array by taking and not taking also, in every step of recursion I am deciding whether I will take or not take. And after when you are returning from all those, what is the total number of times that I have got to make the amount correctly, I will return both of the ways. Okay, I will just add this take or not take. So it's the same thing, almost the same thing which you do. Okay, return 0 on declared identifier I. So I is nothing but index. Okay, I is nothing but index. You see, you have the accepted thing. If you try to run this, it will definitely give a TLE. Okay, so I will just quickly write this thing in order to save from the TLE. Okay, I will just write this quickly. You have two states again. This index, and again the same value, amount plus 1. Okay, you have this as -1. You pass this dp, you write a vector of vector here also. Okay, so you write it and you pass the dp in the other functions also as you have written it. You see the steps I have shown you is the exact general method, right? You can use it anywhere, you can use it in most places. Okay, so if this dp of index, if this dp of index is not equal to this -1, you need to return this dp of index only. There is nothing much you should do. And if the dp is empty, you can just save it. You can just go ahead and save it. And once you save it, just do this take plus not take, and you just return dp of index and also curve. Okay, so you have it, you have all the things. So what can you do now? What can you do now? Let's try to check it if it works. If it works, we will submit it. And so what is the error here? I did not close the bracket properly. Okay. Let's try to check now. We do have the accepted thing. You see the TLE will also be gone now, most probably. And you see the TLE is gone. So you on your own, you write this tabulation method. So you write the task only. I'm giving you the task is that write the tabulation method in the exact same way as I have explained from point change one. Exact same way you just need to do. Okay. Think a little bit. Think a little bit. Exactly. It's nothing different. So task is write the tabulation code and write in the comments. Okay, in the comment section you write the tabulation code. And I hope these variations of this knapsack types variation also you are feeling it right really easy, right? I think this should be very easy for you. Okay, so it's all about practice. So we did some practice about the knapsack like variations. There are some more variations also where there might be difficulty. You might find it difficult to understand that this is a knapsack. Here still you are still understanding it somehow, but there might be some more difficult variations. So some different types of knapsack variations, I will try to cover it in the next video. Maybe one or two problem we'll do, and then we will move on to DP on grid. So yeah, that's all. That's all for this video. If you liked it and if you still feel, I should think that you should still feel that as of now DP is easy. Okay, as of now whatever we have done so far, DP, it should be easy for you. Okay, it is not difficult. It is not difficult at all. So if you think DP is easy and you have watched all my videos so far, you can just comment that. You can comment that in the comment section. Okay. So yeah, that's all. That's all for this video. Meet you in the next video, and hope you have a nice day ahead. Okay. So thanks a lot. Thanks a lot.